about linear equations, so I might as well go ahead and talk about quadratic as well. A little bit more difficult, but we got it. We got it. First of all, quadratic means that you see a x squared, or you see some variable that's squared in the equation, or even a variable that's cubed. You could probably take the same approach, or to the fourth power. You don't just see an x. Okay, the two examples that I have on the paper are quadratic equations, and we're going to try to solve these with traditional factoring. The first example, you want to start out by making sure that they are in standard form. And what I mean by standard form is that you want everything to be on one side of the equation and then 0 to be on the other side. So what I'm doing is subtracting the x from both sides and subtracting the 3 from both sides. And as you notice, it creates an equation that's in standard form. Now, I'm going to see if I can just factor this the traditional way. It looks like I'm going to have to use the AC method. The AC method is where I take the first number times the last number, and I try to find a way to make 4 terms. The video is below in the description box if you need it, though. So I take 2 times negative 3, that's negative 6. I need to multiply to get negative 6, add to get negative 1. That's negative 3 and positive 2. So I rewrite the middle term using the negative 3 and the positive 2. That creates 4 terms. Then I can do factor by grouping. Look at the first 2 terms, pull out a common factor, which is x. Then I look at the last 2, the common factor is 1. The parentheses look the same, so I bring the common factor out to the front, and I'm left with x plus 1. Now that I have this factored completely, I'm going to set each one of the factors equal to 0, and I have to go over to the side to do this. So I set 2x minus 3 equal to 0, and I solve for x. So I add 3 to both sides, and then I divide by 2. The next factor equal to 0, and I get x plus 1 equals 0, so x is equal to negative 1, and this is my second answer. So the second example, I'm also going to look at this one and see if I can just use traditional factoring. And it looks like I can take out a GCF for this one. It's going to be x, and then I'm left with x and x plus 8. So this is completely factored. So I set each one of these equal to 0. I have x equals 0 and x plus 8 equals 0. So x has to be. If the traditional factoring does not work, you can try some other techniques. I want to talk about one called the square root property. So let's take a look at that one. So, square root method. Let's check and see how this goes. Let's say you have x squared equal to p. X squared equals to p implies that x can be equal to the square root of p, or it can be equal to negative square root of p. So you have 2 different values that you can have. For example, let's use a number instead of the variable p. Let's say if we had x squared equals to 25. Then there's 2 values of x that work. X could be equal to 5, or x could be equal to negative 5. So sometimes you'll see it written using this plus or minus notation. So x is equal to plus or minus 5. So let's look at an example where we can utilize the square root method. If I had something like x squared minus 48 is equal to 0, and I'm told to solve it, what I'm going to do is try to isolate the thing that's squared, which is the x. So I'm going to move the 48 to the other side by adding it. So I get x squared is equal to 48. Now that I have the x squared isolated, I can square root both sides. Square root here, and I'm going to tag that plus or minus to the front because I know I'm going to have 2 answers. So x is equal to plus or minus the square root of 48. 48 is not a perfect square, but what I'm going to do is take out any perfect squares that are in 48. So I can break the number 48 up into 16 times 3 because I can actually take the square root of 16. And so my answer is x is equal to plus or minus square root of 16 is 4, square root 3. Let's try another example that we could use the square root method with. So we have this example, x minus 2 squared is equal to 16. You can use the square root property for a problem like this as well. So I have the thing that's squared. In this case, the thing that's squared is x minus 2. So because that is on one side by itself, I can utilize the square root method by square rooting both sides. Making sure to put the plus or minus there. And once you take the square root of something that's squared, you just get what's inside the parentheses, x minus 2 is equal to plus or minus 4. So I have x minus 2 is equal to 4, and x minus 2 is equal to negative 4. And I'm going to continue to solve these because I can bring the 2 to the other side by adding it. So I get x is equal to 6, and x is equal to negative 2. If the quadratic equation is not set up correctly for the square root property, you could do this thing called completing the square. Let's take a look at that. So for completing the square, you have to have a quadratic equation that's set up in this form. X squared plus bx equals c. An equation that's set up in this form cannot use the square root method because you can't take the square root of both sides because you have x squared and you have x. So we have to do something different. It's called completing the square. So let's look at an example and see if we can get it set up in this form. Let's say I have x squared plus 5x minus 8 is equal to 0. So if I move the 8 to the other side, I'm going to get x squared plus 5x by itself, and then I'll have 8 on the other side of the equal sign. So notice how this form looks exactly how the equation looks at the beginning, the x squared plus bx equals c. That's the form that I want this to be in because I have to have it in this form in order to do the completing square. So at this point, I take the number that's with the x, which is a 5, and I divide it by 2. And then I square it. So you do two things. You take the 5, you divide it by 2, and then you square it. And that's going to end up giving me 25 over 4. Now, that 25 over 4, I have to add that to both sides of my equation because whatever you do to one side, you have to do it to the other side. So I put 25 over 4 on both sides. This is me completing the square. Once you do that, you are able to factor the left-hand side. The x squared plus 5x plus 25 over 4, you can factor that. And a shortcut way to factoring that is just take the square root of the first term, which is x, and square root of the last term, which is going to be 5 over 2. And then you put the plus sign in the middle and it will be completely factored. If I combine the terms on the other side, the 8 plus 25 over 4, I end up getting 57 over 4. And now this is set up in the perfect form to do the square root method. So I take the square root of both sides, making sure I put plus or minus, and I end up getting x plus 5 over 2 is equal to square root of 57 over 2. Make sure you put the plus or minus. And the last step is to move the 5 over 2 to the other side by subtracting it. So my final answer after all of that is going to be x is equal to negative 5 over 2 plus or minus square root 57 over 2. Let's look at another example. So I have 2x squared minus 8x minus 5 is equal to 0. And I'm trying to get this set up in the form that I mentioned at the beginning, the x squared plus bx equals c. So I need to move the 5 to the other side because I want to get the two terms at the beginning. I want them to be by themselves. So I move the 5 to the other side and I get 5. And I also need to get rid of this 2 in front of my x squared. So I'm going to divide everything by 2. And once I do that, I get x squared minus 4x equals 5 over 2. Now this is set up in the form that I need. I have x squared minus 4x, and then I have a solid number on the other side. So now it's time to complete the square. And I'm going to take that number sitting right in front of my x, which is negative 4. I'm going to divide it by 2, and then I'm going to square it. And I end up getting 16 over 4. So it's going to be 4. So I take 4 and I add that to both sides. Plus 4, plus 4. When I put the plus 4 there, that means I've completed the square and I can factor. So I get x minus 2. I got minus 2 in this case because there's a negative sign in the middle. So x minus 2 squared, and combining 5 over 2 plus 4 is 13 over 2. Square root method. Take the square root of both sides, and you get x minus 2 is equal to plus or minus square root of 13 over square root of 2. I can't take the square root of 13 or 2, so I keep them both underneath the radical. Next step is to move the 2. So I add 2 to both sides, and I end up getting x is equal to 2 plus or minus square root of 13 over square root of 2. But I can't stop there because I have a radical in my denominator, and I can't have a radical in my denominator as a simplified answer. So what I have to do is this thing called rationalizing the denominator. What you're going to see me do now is I'm going to multiply the top and the bottom by the radical in my denominator, which is square root of 2. I'm going to multiply the top and the bottom of this fraction by square root of 2, because that's going to make my denominator, the radical in the denominator, go away. So when I multiply the top, I get square root of 26, and at the bottom I get square root of 4, which is just 2. And this is called rationalizing the denominator. Some of you may run into this issue with a couple of examples, but I want to make sure I did one that shows you how to rationalize the denominator so you get the correct answer.
Last but not least, let's say you are just completely lost on how to solve the problem, then you always have the quadratic equation to help you solve the problem as well. This is like a last resort type of technique, but it works every time. It's a little bit tedious, but it gives you the correct answer every single time. And a lot of students enjoy this method because it's the easiest one to follow.
Okay, quadratic formula. This right here is the quadratic formula. X is equal to negative b plus or minus square root b squared minus 4ac, all of this over 2a. So where does the a, b, and c come from? If you look at a quadratic equation written in standard form, which is the x squared is first, the x is second, then the number is last. The a, b, and c are the coefficients that are sitting in front of each one of your terms. So the first term is a, the second term is b, the third term is c. And you take those numbers to plug it into the quadratic formula. So let's look at an example. I have 3x squared minus 5x plus 1 is equal to 0. So this is already in standard form. So a is equal to 3, b is equal to negative 5, and c is equal to 1. So I'm going to take those values and plug it into the formula above. I have negative b, so I put negative, and my b value is negative 5, plus or minus square root negative 5 squared minus 4 times 3 times 1. And all of this is over 2 times my a value, which is 3. So everything is plugged in. Now I just have to simplify it. So let's condense this. The negative and negative come together to make positive 5. Then negative 5 squared is 25 minus 12 all over 6. So I do 25 minus 12, which is going to give me 13. And I can't take the square root of 13, and there's no perfect square within 13. So this is my final answer. X is equal to 5 plus or minus square root of 13 over 6.
So I hope that was helpful. Leave any comments below, and I'll see you next time. Bye.